So we're going to go through it here together. This first part, you don't have to think of it as a product rule, but I'm assuming that most of you did, so that's the way I'm going to do it. So we're going to start with first times derivative of the second. Well, derivative of e squared, well, there's not a variable in the base. There's not a variable in the exponent. If this were e to the x, then it would be a different story. But what's happening here is that e squared is just a number. It's like 8 point something. So e squared is just a number. So the derivative of e squared is 0. And then plus our second times derivative of the first. Well, our second function is e squared times derivative of the first. Now derivative of x is just going to be 1. Minus, so now we're looking at derivative of e to the x. Well, derivative of e to the x is just e to the x. So even as you take derivatives going down the line, derivative of e to the x is going to keep being e to the x. Second derivative is also going to be e to the x. Third derivative is also going to be e to the x. It's like an old broken down car, e to the x is. You can derive it all you want, but you're not going to get anywhere. Derivative here, this is just, this is not anything from exponentials. I could have given you this a month ago, and you should have been able to tell me that, oh, there's a number up in the exponent. Well, that means negative square root of 2 comes out in front, and then subtract 1 from the exponent. It's the same idea as this one. So remember, if the variable's in the base, then it's just, and a number's in the exponent, it's just a power rule. So if you got a number in the exponent, just a power rule. The variable in the exponent, that's when we have our exponential rule. And so if we've got a number to the x, similar idea of e to the x, the derivative of 8 to the x is 8 to the x. But then our rule says that we need to multiply by the natural log of the base. So our derivative of 8 to the x is 8 to the x times the natural log of 8. Done. That's our derivative rule there. Questions on either of those? We might do a couple more at the end together on these if we're having trouble. But I want to move on to some new derivative rules here. And these are our last derivative rules here. And just like number to the x and e to the x are related, log and natural log are very similar to each other. So here's what you're going to have. Let's say, let's take an actual example here where we have a log. Let's say we have log base 5 of x. The derivative of that, all we're going to do is we're going to do the same thing we did for exponentials where we take the natural log of the base. And so it's going to be 1 over our argument. In this case, that's x. So 1 over x times the natural log of the base. And so our base in this case is 5. So remember that the base is the number down here in our logarithm. So it is 1 over x, but then we need a natural log of the base in there. The difference with natural log is that the base is e. So that means when we multiply by the natural log of the base, we end up with natural log of e, which is just 1. So this simplifies to just 1 over x. All right, let's look at some examples here. We will start with natural log here. Since that's kind of the more simple rule here. So derivative of natural log of x squared is going to be 1 over the argument. So 1 over x squared. 1 over whatever's inside here. But then we're going to need the chain rule. Multiply by our derivative of the inside part. Derivative of x squared is 2x. So we can actually do some canceling and say there's a 2 goes on top. And then this x up here cancels with this x squared down here. And we just have 2 over x. Part B. Part B is a little bit trickier, actually. There's an easier way to do it, but I'll show you that in just a second. The tricky part here is that we're going to have a fraction and a fraction at first. So we have 1 over x. 1 over whatever's inside here. But then, of course, since there's something inside the natural log, we're going to use the chain rule. Multiply by the derivative of the inside part. Derivative of 1 over x. That's going to be x to the negative first. So derivative of x to the negative first is going to be negative 1 times x to the negative second. So that means it's going to be a negative. The negative second means it goes down at the bottom. Oh, and down in the denominator, that means we get this squared canceling with this x here, and we just get negative 1 over x. So another way you can actually catch this is if you realize that this is the natural log of x to the negative first. And if we have natural log of x to the negative first, this negative 1 up in the exponent means, if you remember your properties of logarithms, if I got an exponent inside of the logarithm, then I can just bring that negative 1 out in front. And so this is the same as the negative natural log of x. So that means the derivative is going to be negative. Derivative of natural log of x is 1 over x. So if you can catch that simplifying, then it can make things a little bit easier. Next up, natural log of x plus 2. Derivative of natural log of x plus 2 is 1 over whatever's inside. So x plus 2 is inside. But of course, we need the chain rule. But good news, derivative of x plus 2 is just 1. So not a lot of fancy work happens there. Boom. 1 over x plus 2, final answer. Next. Natural log of 2 minus cosine of x is 1 over whatever's inside the logarithm. So 2 minus cosine of x. times derivative of the inside part. Derivative of 2 minus cosine of x. Well, that is 0 minus derivative of cosine is negative sine. So we got a positive sine of x on the top, and then we have a 2 minus cosine of x on the bottom. All right. I actually want to leave part E for you to try on your own and see if you can get it. So when you turn in the notes, I'll double check that you have those correct. So try part E on your own. As we move down to doing some log rules, we won't do as many of these because they're very similar ideas. The only difference is that we need to remember to put a natural log of the base in the bottom. So this rule is going to be very similar to the one we did with natural log of x squared. So y prime is going to be 1 over x squared. The only difference here is that we need to remember to multiply by the natural log of the base. So the base here is 4. So natural log of 4 goes on the bottom. And then just like we did with natural log, we need the chain rule. Inside of our log base 4 function is x squared. So times derivative of the inside part, derivative of x squared is 2x. So we can say that this is 2, and then these x's cancel with the x squared here. So we get x. Then we need natural log of the base here. Next one. Log base 2 of 3x plus 1. So 1 over whatever's inside the logarithm. But then we need to remember to stick a natural log of the base on the bottom. So natural log of 2 times derivative of the inside part, derivative of 3x plus 1. Well, that's easy. That's just 3. So we can rewrite this as 3 over 3x plus 1 times natural log of 2. And we'll do one more together. One more together. We're going to do this one. Now remember that this is multiplying two things, but just like I talked about with an earlier example, this is just a constant. Natural log of 2 is a number. So when we do this, we can just say that y prime is, we're going to have natural log of 2 times the derivative of log base 2 of x. Well, derivative of log base 2 of x is 1 over x times the natural log of the base. If you want to do this as a product rule, you can do it as a product rule, and you're going to get the same answer because derivative of natural log of 2 is 0. So that second term is going to cancel out. Hey, natural log of 2's cancel. It's almost like the problem was set up that way. Because this is the same as natural log of 2. Again, if you remember your rules of logarithms, you can rewrite this with a change of base formula as a natural log of x over natural log of 2. and then these cancel, and this is just natural log of x. Guess what the derivative of natural log of x is? Would you look at that? So sometimes if you're really good with your logarithms and your tricks with the rules of logarithms, you can have a much easier time with taking these derivatives. But if you don't spot it, then you can just do it the way you would normally do it. And it'll work just fine that way as well. So same thing on part C, actually. If you catch the logarithm rule that you can use, then it can be easier. If you don't, then you can just do it out the way that we've been doing all the others. And some things will cancel.